Hi, my name is Subramonyam, and today I'm going to talk to you about our work on model-informed prototyping for AI-powered interfaces. This work is in collaboration with Colleen Seifert from the Department of Psychology and Eytan Adar from the School of Information here at the University of Michigan. Let us imagine designing an application for a bird watcher to keep record of all their sightings. As a designer, you will identify the key information that the bird watcher may wish to record and transform those requirements into a sequence of task items. In this case, the bird watcher needs to first capture or upload a photo of the bird. Then they need to enter the name of the species, and optionally, they may want to enter observational notes about the bird. To support these tasks, you will design an interface by mapping each task item to a user interface element. And this is what a typical user interface design process looks like. A problem with this interface design is that there are thousands of bird species, and bird watchers, especially novices, may not know the name of the sighted bird, and manually entering the species name can be challenging. As a solution, you may consider using machine learning to identify the bird species from images. So the user uploads an image of the bird, and AI automatically detects the species. You modify the interface from a text box to an AI-generated label. Now, if the underlying machine learning model is really good and always accurate, as a designer, your work is done. But unfortunately, these models are error-prone, and as a designer, you need to design for model uncertainties by considering the interactions between people and machine learning. Specifically, you need to design for AI errors and handoffs such as mixed initiative dialogues. You need to design ways to support model learnability through feedback and also help users understand the model's output through explainability. All of this requires that you are able to explore the model's behavior firsthand with diverse input data, such as variations in input images ranging from birds at flight to a flock of birds in the picture. You need to ensure that the bird classifier covers bird species across different geographies. And you need to design the AI-powered user experience by considering diverse users from novices to expert bird watchers. Unfortunately, most UI prototyping tools assume a black box view of AI, making it challenging for designers to explore model behavior and access model features and outputs during the prototyping process. Designers may need to work with separate tools for model exploration and interface evaluation across diverse users and contexts of use. And this could disrupt their rapid and iterative prototyping workflow. A motivating question for this research is how might we support designers to directly incorporate target AI features when prototyping AI-powered user interfaces? By analyzing over 280 human AI design guidelines, we identified a set of design considerations for prototyping tools to operationalize the guidelines. We request that you refer to the paper for details, but at a high level, our approach combines model exploration, UI prototyping, and design evaluation in a single workflow that we call model-informed prototyping. We developed ProtoAI, a tool that implements model-informed prototyping. At a high level, ProtoAI's interface has 4 main tabs. The first is a collection of machine learning models and services that the designer can incorporate in their prototyping process. The second is a data view for exploring the models with diverse input data. The third is the user interface prototyping view. And the last tab is to evaluate the interface design across diverse data. And designers can flexibly work across these 4 views. Let me give you a walkthrough of how the designer might use ProtoAI to design the bird logging app. The designer first selects the image classification model and then navigates to the Data tab. Based on user research, the designer has curated a set of images of different bird species. They upload this data from a CSV file. It consists of images and a ground truth label. The designer configures these columns in the model card on the right and then runs the model for the uploaded data. For each image, the model returns 3 labels along with corresponding confidence scores. Next, the designer navigates to the User Interface tab and prototypes the main logging view. After adding a header, they navigate to the Data Elements tab. Here they see the input data along with the model output, which they can directly incorporate into their interface design. After prototyping an initial layout with the image and the model-generated label, the designer navigates to the Data Previews tab. Here, they can see auto-generated previews of the interface design for all of the input data points and corresponding model outputs. Based on the ground truth data supplied by the designer, ProtoAI automatically tags erroneous classification instances. To further investigate these errors, the designer navigates to the Interface tab and includes a confidence score on the interface. Because this is meant for the designer to investigate the errors, they toggle the is explanation flag on that element. In the Previous tab, they see that labels with confidence value that are less than 60 tend to be incorrect. To mitigate these errors, the designer decides to create a new interface layout for instances with low confidence scores. They set this up by specifying the classification accuracy less than 60, then they show this new state to the user. In this new state, the designer prototypes a mixed initiative dialog by presenting all of the model labels along with the option for the end user to enter their own label. In the Previews tab, they see this new state applied to instances with erroneous labels. Similarly, the designer can evaluate the design with variations in scene, in this case, different images of sparrows. And they can, through this process, they can design end user feedback when there are multiple birds or when the birds are in flight. ProtoAI also allows designers to transform model outputs into end-user-friendly formats for presentation. Here, the designer is transforming the confidence score into a categorical value of high or low. Lastly, ProtoAI allows designers to flexibly set the data context for the interface and design across different user personas. The widget features make it easy to prototype for standard AI design patterns. In summary, in model-informed prototyping, designers can directly work with diverse end-user data, incorporate model features and outputs into their design, supply ground truth values, and create derived data to rapidly and iteratively prototype AI-powered interfaces. ProtoAI offers the flexibility for designers to specify model requirements upfront through hard-coded data, or incorporate existing models and services into their prototyping process. Designers can simulate a variety of usage scenarios through the facets and interface states features in ProtoAI. Such a workflow could allow designers to prototype diverse AI experiences. Recall Twitter's biased image cropping issue. ProtoAI could allow designers to evaluate model performance upfront with a variety of images with different background and foreground objects and foresee the need for manual cropping features. In a different scenario, such as designing user experience over time, the designer can start with personas with different interests and time of use and simulate learnability and usage over time. And as shown in the earlier demo, ProtoAI could allow designers to prototype mixed initiative dialogues to account for AI's uncertainties. Thank you for watching.